guys, if you are watching this video, it is because I am gone today because of jury duty, like I said. So, we are going to be talking about the fundamental counting principle today. But just to start off, if you needed help on a question that was on pages 12 and 13, go to Google Classroom, go to the private comment part of that assignment, and type in your question for me, and I will be more than happy to answer you. So I will answer that question for you. If you send me a question, you can also email me your question if you have one. Reminder again, if you did not submit the picture to Google Classroom, please make sure you submit that picture to Google Classroom so I can grade your homework assignment, but you will check your homework assignment for accuracy in class. So if your homework assignment is late and you did not check it in class, you will have to turn it in after school like usual so we can check the accuracy of your homework assignment. The sub is writing down who did not turn in their homework, so I will know if you turned it in on time for class or whether it was late for class. So please make sure you're honest with me. I would greatly appreciate it. So with the fundamental counting principle, we got to start out with a tree diagram. So on this lime green sheet of paper, we're talking about tree diagrams. And tree diagrams, in many cases, there means that there is more than one action or more than one choice, which results in several different outcomes. Tree diagrams are a useful tool to organize and show all of the possible outcomes. So what I mean by that is, for instance, number one, the spinner below is spun twice. So I have this spinner right here. I have an A, B, and a C. It is spun twice, which means if I spin the spinner, I have the chance of spinning an A, a B, and a C the first time. Then after I've spun it one time, I want to spin that spinner again. So if I get an A the first time and I spin that spinner again, I have the chance that I can get an A, a B, or a C. Because just because I spun an A, that does not affect my second spin. So if I spin an A the first time, I can spin an A, B, or C the second time. If I spin a B the first time, I can still spin an A, a B, or a C the second time. Then if I spin a C the first time, I can spin an A, a B, or a C. So that is my tree diagram right there. I can get an A, a B, or a C the first time, and then when I spin it again, I can get an A, a B, or a C, an A, a B, or a C, an A, or B, or a C. Hopefully that makes sense. Okay, so then what I do is I write my sample space. And if you guys recall from our very first lesson on probability, the sample space was that really funky looking bracket that's really difficult to draw, so just do your best. Don't really care what it looks like. But you're writing down all of your possible combinations. Okay, so the combinations are I can spin an A the first time and an A the second time. So my probability, or one of my options, is I can spin an A and an A. I can then spin an A and a B. I can then spin an A and a C. I can then spin a B and an a B and a B and a C and an A. Sorry guys, I have my kids here, so I apologize. Not much I can do about it. So anyway, back to this. I can get a C and an A, or I could have the combination a C and a B, or I can have the combination a C and a C. And that wraps up my sample space because it is all of my possible combinations that I can get with spinning my spinner twice. So hopefully that made sense to everyone, which means that the total number of combinations I have is 9. I have 9 possible combinations. So when I look here, I want to know the probability of getting a B twice. So if I look at my sample space, I see that I have a B, which is B twice, 1 out of 9 times. Then I go to B. I have the probability of at least one A. So I need at least one. I get okay, so I want at least one A. So when I count here, I want at least one. So there's 1, there's 2, there's 3, there's 4, there's 5. Okay, so I have 5 combinations that have an A out of 9 total. Hopefully that made sense. Then probability of this last one says no C, which means I'm going to count up all of my possible outcomes that do not have a C. So 1, 2, 3, 4. Those ones all have C's, so that means I have a 4 out of a 9 is my probability that I will get no C. Hopefully that made sense. We are not going to worry about percentages or decimals. Just make sure they are fractions in simplest form. Okay, I'm going to do number 2 with you guys as well. So let's go to number 2. So number 2 says the popcorn stand offers buttered or unbuttered popcorn. So that means your first choice you can choose is, do you want buttered popcorn or do you want unbuttered popcorn? Then you can pick the size. You want a small, a medium, or a large. So if I choose buttered popcorn, I can choose a small, a medium, or a large. And I'm going to abbreviate, okay? If I choose unbuttered popcorn, I can still choose a small, a medium, or a large. It doesn't matter if I choose buttered or unbuttered, but I can still get a small, a medium, or a large. Hopefully that tree diagram is making some sense to you guys. So then I'm going to draw my sample space, which is that funky looking bracket, and then I'm going to abbreviate it. I can get buttered with a small, I can get buttered with a medium, and I can get buttered with a large. I can then get unbuttered with a small, unbuttered with a medium, and unbuttered with a large, and then I will close my bracket. So that means that I have a total of 1, 2, 3, 4, 5, 6 combinations, and then I can start doing my probability. So I want the probability of buttered. Well, the probability of buttered, I've got 1 buttered, 2 buttered, 3 buttered. So I have 3 buttered out of 6 total. And that 3/6 simplifies down to 1/2. Then I want the probability of a large. Well, I can get a buttered large or an unbuttered large. So that means that I have 2 larges out of 6 total, which simplifies down to 1/3. Then the last one, I can get the probability of a small with no butter. So that means that I need unbuttered, and it needs to be in a small. So this is a small, but it's buttered. This is a small, it's unbuttered. So that means that there is 1 small that's unbuttered out of 6 total. And that is the probability of those 3 answers. Okay, so those are the 2 that I'm going to do with you. You guys are going to do number 3 on your own. I would choose to stop this video right now, put it on pause, answer that question. When you have answered that question, I would go check in with the sub. She has the answer listed to make sure you did this right. Once you get this answer correct, then you may go and continue this notes video. So pause it now, answer that question. When you're done and you got 100% on it, come back and continue this video. Alright guys, so now you can flip over to the fundamental counting principle, and this is essentially what your homework is going to be on tonight, is this principle. The tree diagram is very helpful, but the fundamental counting principle is really good for when numbers get to be very large. Okay, so this is what it says. The fundamental counting principle means you can use the counting principle to find the total number of outcomes. So for instance, if one activity can occur in m number of ways, and another activity can occur in n number of ways, then both activities can occur in m times n ways. So for instance, if I flip back to this page, okay, I had 3 outcomes here and 3 outcomes for the second round. So 3 times 3 is 9. Here I had 2 outcomes, buttered and unbuttered, and 3 outcomes in small, medium, and large. So 2 times 3 is 6. So it gives you your total combinations. Okay, so hopefully that made sense, because then if we go back to this page and I go to number 1, it says To leave her office, Karen can choose between 3 sets of stairs and 7 doors. So how many ways can she leave her office? Well, if she has 3 sets of stairs and 7 doors, all you have to do is take 3 times 7, and she has 21 different ways that she can leave her office. Okay, so for instance, we keep going. Number 2, a sweater comes in 4 sizes and 8 colors. How many different possible combinations are there? So what that means is I take the 4 sizes and I multiply it by the 8 colors, which will give me 32 different possible combinations that I can get. Okay, so hopefully that made sense. Okay, hopefully that made sense. I'm going to have you guys do 3 and 4 on your own, and then you will take those and check those in with the sub to make sure you did them correctly. Okay, we're going to do number 5 together. Number 5 says a card is chosen from a standard deck of cards, then a die is rolled. How many possible outcomes are there? So that means that if a card is chosen from a standard deck of cards, I have to remember how many cards are in a deck of cards. Hopefully over these last couple days you remember that there are 52 cards in a deck. Remember, jokers do not count. And then a die is rolled. It's a regular die. Okay? So that means that if it's a regular die, it's a 6-sided die. So I'm going to take 52 and multiply it by 6. You guys are allowed to use your calculators. That's totally fine. Just make sure you tell me 52 times 6 equals to get your answer. And when you do 52 times 6 in your calculator, you end up getting 312. So there are 312 different possible combinations for number 5. So just a reminder on that one, when it said a card is chosen at random, there were 52 cards in a deck, so that's how we came up with that number. And then we came up with 6 because that's how many sides are on a dice. So I'm going to have you guys do number 6 on your own. Check your answer with the sub. You're talking about a quarter toss, so think about how many things you get with a quarter being tossed, and then a letter from the word, and you multiply them together. Okay, number 7, I'm also going to have you do, and then turn that one into the sub. A day of the week is chosen, so how many days are in the week, and then this spinner is spun twice. So think about what that means. If it's spun twice, how many options do you have for the first spin? How many options do you have for the second spin? Combine them together. Okay, we're going to go do number 8 together because 8's a little tricky. It says, how many ways can someone randomly dial a 7-digit phone number? So if you're looking at a phone and you think about all the numbers that are on the phone, you've got the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. That means there are 10 digits that are on a phone. So that means with my first number, and it's a 7-digit phone number, I would have 10 total options. For my second number, I still have 10 total options because I can get a 4 the first time, I could get a 4 the second time, or I can have a 4 and the 0. And then my third option, I have a 10. There are 10 options, 10 numbers for the first number, 10 numbers for the second number, 10 numbers for the third number, which means that there are 10 numbers for every single digit of that phone number for options. So 1, 2, 3, 4, 5, 6, 7. 7 digits, 10 different number options for those 7 digits. We could also write it as 10 to the 7th power. And 10 to the 7th power is 1, 2, 3, 4, 5, 6, 7 zeros. And then just make sure you put your commas in the correct spot, which means your answer is 10 million different ways to come up with a random 7-digit number. Okay, so based on that question number 8, I now want you to do number 9 on your own. Okay, and then let's do number 10 together. very similar to 8 and 9. This time it's talking about the library codes their books using 2 letters. So if it's 2 letters, it's like AA, AB, AC, whatever the case may be. So that means that my first option, I have 26 letters because there are 26 letters in the alphabet. So the first letter, I can have 26 options for a letter. The second letter, I still have 26 options because there are 26 letters in the alphabet. So option number 1 is 26, option number 2 is 26. And then followed by a digit of 0 to 9. Well, 0 to 9 we just did on the one above. If it's 0 to 9, there are 10 numbers, which means I would multiply it by 10. So it's 26 letters times 26 letters times 10 numbers. And when you do that math in your calculator, you get 6,760. And once again, use your calculator. You do not have to do it without a calculator. So now is the point where you guys need to stop your video. You need to do 3, 4, 6, 7, and 9 on your own. Go check them with the sub. If you missed any, you will need to correct those problems. Once you get them right, you will be allowed to restart this video and continue with your homework because you are done with your notes video. I hope that made sense. If you have any questions, you can shoot me a private comment on the homework for worksheet 14. You can shoot me an email. You can leave a comment, whatever you need, just let me know. Hopefully I will be back on Thursday, but I do not know that when I'm making this video. So we will find out. So like I said, pause the video, do these 5 questions, check them, and then come back so I can explain your homework to you. Okay guys, so your homework assignment is page 14 and only page 14. You are allowed to use a calculator on it. Okay, so if you need to write that up at the top, write that up at the top. You can use a calculator. And on this page, you're really only giving me number answers. So you need to show me the work, what you multiply together, what the answer is. So you'll do that for every single one of 1 through 8. So just tell me what the total number of outcomes is in each of those situations. Work, do the calculator, write down your answer. Okay? Then for 9 and 10, these are going to be more probability-based questions. So a little bit more like what we did with the tree diagram. You'll have to figure out the total of outcomes that are possible, just like you did up here. But then you'll tell me how many possible out of how many total, and then same thing for number 10. So do your best on that. I only need fractions in simplest form for 9 and 10. No need to do decimals, no need to do percentages. You can leave it at that, okay? Then when you are done with page 14, you do need to take a picture of this, turn this page into Google Classroom just in case, because I have no idea what's going to happen tomorrow. So please turn this into Google Classroom. Please make sure that I can read it. If I cannot see it, I will not be accepting it. Same thing with the assignment that was due today. So please follow those directions. I would greatly appreciate it. Message me, email me if you have any questions or concerns. I will be more than happy to help you, and hopefully I will see all of you guys on Thursday. Have a great rest of your day and night, guys. Bye-bye.
I found this